Now we're in chapter 5. Okay, now chapter 5, here we're saying defining polynomials. So basically the whole section here is just to touch upon what polynomial is all about, right? Okay, so where did we go about this one? I just want to, yeah, it's pretty good. So use the blue color. Okay, so now let's take a look. So there are just certain terminologies that we need to become more familiar with in order to go along the other sections. So variable. Now this is what I'll know. Variable is a letter. Okay, variable is just a letter. And then the term. So what is a term? Term means this is a product. Product means multiply together, a number and a variable. Or and raised to a power. Now raised to a power. So this is not, this is all combined. So the product is product and a number, product, a number is one thing, and a variables raised to a power. Okay. Now let's consider this as a whole thing. It is this. Okay. So that means any term will be a number. Just say n. Use n as a number. And then it will be a variable. What do we use? Okay, we just use a v, a variable. And then also needs to be a power. So really, okay. So now, for example, now y5 here, is considered as a term. There's no variable, let alone there's a power. Okay, what does that mean? So now here, sure, this one is a number which is 2, and x, so means product means 2 multiplied by x, right? Now, yes, raised to a power. Now, what is the power of x here? Sure, power 1. Okay, perfectly fitting for the definition of a term. Now, here we go. Now, this one, what is the number? Okay, the number is 3. The product, sure, multiplied by. Now, the variable, we still use the x, fine. And to the power of 2. Okay, beautiful. That it works. Let's go along with the definition. Now this one here, okay, so you see here, a number, sure, still a number, one number, -2, and it says variables. So here we go. There is one variable, x, there's another variable, y. Now their power, sure, power 1, power 1. Okay, so this is absolutely fitting. They are fitting. Now, seriously, don't you want to ask about what's going on with this one? How we can say one number is a term. Now, where does this one go? Where does that one go? Now, think, all right? Think what happens here. Right. Okay, so why don't we say, the number is 5, all right? Okay, variable is x, no worries. And the power, how much should be the power? Power is 0. Well, then that turns out to be x to the power of 0 is 1. Then, of course, then it becomes 5. So, sure, I have a number, I have a variable, and I have a power. It does fit into the definition of a term. Well, if that's true, I can further think that could be also be written in x and y and z, oh, and a and b and c. Doesn't matter, I can continue, but whatever all these letters, every single one of them, the power is 0. Therefore, after all, this is just 5. Okay? So, that's this one, the term. Now, after that, we also have a definition called coefficient. Now, coefficient just means this is this number here. This number here is the coefficient. All right, so that is a numerical value or numerical factor. Because why do we call it factor? It's because they're all products. So they all multiply each other, then each one of them is a factor. This is a factor. This is a factor. This is also a factor. And x is a factor. Another x is another factor, right? They multiply together. Okay, so now we have monomial and binomial, trinomial, and polynomial. Okay, so now polynomial is poly. This word is Greek word that means many. Many. Okay, so now at the beginning, when we started started the study of algebra, means that we use a letter to represent a unknown number or a number that can be anything. We used binomial, so two terms, all right? And then many terms become the polynomial. Okay, so monomial is just only one term. Polynomial is many terms. Many terms, see, as many. This is a trinomial because this is 3. This is a monomial, that's only one term. This is binomial, 2 terms. And trinomial, 3 terms. Or on top of that, we can say polynomial. Anything beyond 2 terms is polynomial. Okay, so then after that, we have another definition. What is a degree of a polynomial? Degree of a polynomial. So that means it is the sum. It is a sum of the exponents of its variables. All right? So what does that mean? It does not mean, so the term of, for example, the term of this polynomial, it is 2, because here the highest is 2. But you said, what is the sum of the exponents? Well, then how about this one plus this one? There's a 1. Then why is not 3? Well, this means the sum of 1 terms, okay? So that means take a look at 1 term. So now this term here, and that's 2 variables, but each one of them is the degree of 1. So then the total degree is 2. See that? Okay. Now, what is a leading term? The leading term is a term that has a highest degree. All right? So now in this case, the leading term is 5x to the power 2. Degree is 2, right? And the leading term in this one here, it is the x and y. All right? Because again and again, we talk about this one is called this number. This number, they're called the constant. Why are they called a constant? Because they do not change. Now the other ones, the 5x to the power of 2 and 3x, their value can be changed, can be different, depends on how much you think the x can be. But 4, as a matter of fact, is 4 to multiply by x to the power of 0. And that is 4. We already stated this fact above. And so this 4 never changes. X can be any value, but 4 stays 4. So that is called the constant. Okay. We do not touch the algebra tile today. And then we also talk about what like terms means. This is very important in order to know how to add, subtract, multiply, and divide polynomials. Especially this is adding and subtracting. So like terms. Like terms, so they have 2 things. One is they are the same variable and also exactly the same power. Okay, so they have to have the 2 conditions, the first one and the second one. And if that's a case, then it's called like terms. Okay, So 5x and 3x, that are like terms. Now 2x squared, negative x squared, they're like terms because they have the same variable and they have the same power. So therefore, 3x and 5x squared, they're not like terms. Why? Because their power is different. This is 1, that's a 2. All right. Okay, so then in this case, now it's basically the same as we get into 5.2. So that would be another video. So how can we add them together? All right. Thank you for watching.